Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, my math friends. Welcome. I'm so excited that you are joining me tonight for Wednesday night math night. If you were here last week, you know we experienced some technical difficulties and everything just crashed in the middle of me trying to explain a problem. So we're hoping that doesn't happen today. So I just took the problems from last week that we didn't finish and dragged them into this week. The beauty of technology, you can just plop things over to other weeks. So with that said, before we get started, I always like to get to know who is in the room because it helps me feel like I'm not just talking to a screen, but it also helps me to guide our conversation tonight when I know what test you guys are prepping for. So in the comment section, let me know where you're from and what test you're prepping for. And I always also like to do like a fun get to know you problem or question. So would you rather go in a submarine down to the depths of the ocean or go in a rocket ship to outer space? Would you rather go in a submarine or a rocket ship? So where are you from? What test are you prepping for? And would you rather go in a submarine or a rocket ship? I would rather not do either of those. I'm not an adrenaline junkie. But if I had to pick, I think I would pick a rocket ship because I've always been fascinated with space. And so that's probably what I would choose. So it's good to see you, Caroline. It's good to see you, Cheryl. I'm excited to see some familiar faces here tonight. Hey, Joseph, it's good to see you. A submarine. I mean, ocean animals are really cool. And going to the depths of the ocean, I mean, you'd see things that people have never seen before. So let's go ahead and jump right into it. Oh, hey, Chantel, a rocket ship too. You can join me. Although now they're sending like people who aren't astronauts into outer space, which I think is wild. I don't think I could handle the G-forces of that. All right, let's jump right in. I see a good handful of people are here for the high school, middle school math prep. Some elementary, but it looks like a good portion of people are here for middle and high school math. So let's get started. Problem number 1. Let's adjust the screen so you can actually see the problem. That would be helpful. One day you saw a cool video on social media. At 3 p.m., you shared the link to the video with 5 friends. Then at 4 p.m., each of your friends shared the link to the video with 5 unique people. Then at 5 p.m., each of their friends shared the link to the video with 5 new unique people. If this pattern continues, how many unique people will have received the link to the video by 11 p.m.? Hi, Shannon from Orlando. Go Knights. So there are 2 different ways we can solve this. Honestly, if I was solving this, I'd probably just figure out the pattern and go with it. So I'm just going to kind of show you that way, but then I'm also going to show you another way because sometimes we can't use the pattern. So I'm going to make a table of values, and I'm going to say time, and I'm going to say people. So at 3 p.m., you shared it with 5 friends. Then at 4 p.m., each of those 5 friends shared it with 5 more people. So if this was a person, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Think about what's happening here. We're doing 5 people times 5 people per group. So it's 5 times 5, which is 25 people. Then at 5 p.m., each of these people shared it with 5 more people. So now I'm going to do 25 times 5 to figure out how many people were shared at 5 p.m. That's 125. Then at 6, 7, 8, 9, 10, and 11, each set of people shared it with 5 people. So then we have 625, then we have 3,125, then we have 15,625, then we have 78,125, then we have 390,625, and then we have 1,953,125. So those are all of the people at each hour. But it says how many unique people will have received the link by 11, not how many unique people received the link at 11. If it said at 11, then this would be our answer. But it says by 11 o'clock, so they want all of the unique people by 11 o'clock. So now what am I going to do? I'm just going to add all of these numbers up. Now, here's a calculator trick. I almost assumed that everybody knew this, but I don't ever want to assume things. So once you do 5 times 5 equals 25, because the calculator has now remembered that you've done times 5, you can literally just click the equal button, and you don't have to do times 5 every single time. It's timesing that number by 5 each time. So you don't have to sit and do times 5 every single time. Okay, now I'm going to use my calculator and add all of those numbers up. So 5 plus 25 plus 125 plus 625 plus 3,125 plus 15,625 plus 78,125 plus 390,625 plus 1,953,125. And I get 2,441,405. Now, that really didn't take that long. Maybe 2 minutes if I didn't sit here and explain all of that. However, what if it wanted how many people received the link in 24 hours? We would be here for a while figuring all of that out. So what can we do? Well, what does this look like? this looks like a sequence. We talked about arithmetic and geometric sequences last week, and we're pulling it in this week where we're not finding a specific term, we're finding the sum of the sequence or the series. So is this, let's talk about this. I'm going to copy and paste this slide so that we can solve it a different way. Is this an arithmetic or geometric sequence of numbers? We know this is a geometric sequence of numbers, so we're looking at arithmetic, metric or geometric. We know this is a geometric because the ratio is a multiplication equation, where in an arithmetic sequence, we're looking at addition or subtraction. So because these terms are exponentially increasing and we're multiplying by 5 every single time, we are looking at a geometric sequence here. So the sum of a geometric series is, and this is just something that you have to memorize, sum of n equals a times 1 minus r to the nth power divided by 1 minus r. I'm just going to not even lie to you. I had that written on a piece of paper because I do not have that formula memorized. But you have to have that memorized if this is something that's on your blueprint or your study guide. So this says the sum of this many terms in the sequence is given by the first term times 1 minus the ratio to the how many terms we have divided by 1 minus r. Well, in this case, the first term is 5. That's what our sequence starts with. So we have 5 times 1 minus. Now, the ratio is also 5 because each of those friends shared it with 5 people. So every time we're multiplying by 5 to get to the next value. So our ratio is also 5. But then how many terms are there? Well, we have 3 o'clock, 4 o'clock, 5, 6, 7, 8, 9, 10, 11. We have 9 terms. So it's 5 to the 9th power divided by 1 minus 5 because r is 5. Now at this point, we just solve using order of operations. So 5 times 1 minus 5 to the 9th power. I am going to use my calculator for that. Don't have that one committed to memory. 5 to the 9th power, 1,953,125 divided by 4. So -4, sorry. So the numerator is going to be 9,765,620 because I did 1. What just happened? Because I did 1 minus that 1 million times 5 and then divide it by the 4. And we get the same answer. So like I said, if you don't have that formula memorized, then you have to do it using a table of values. But having that formula memorized is definitely helpful, especially for those larger sequences. How do you figure out which one to use? Geometric sequence or series? So a geometric series is the sum of the sequence, if that makes sense. So like a geometric sequence is like the set of numbers, and then when they are referencing a geometric series, they're really just referencing the sum of that sequence. So hopefully that helps. And then there is, I mean, we're not going to go into it today, but there's also formulas for the arithmetic sum, and then there's formulas for you to find, like if they were like, how many people would have received the link at 4 a.m. There's also a formula that you can find like the nth term of that sequence too. So what is the difference between an arithmetic sequence and a geometric sequence? That's an excellent question. An arithmetic sequence has a ratio where you're adding and subtracting. So an example would be of an arithmetic would be like 1, 4, 7, 10, 13, where your ratio is adding 3 each time. But then a geometric would be 1, 3, 9, 27, and then you're multiplying by 3 each time. So Cheryl, how do you know when to use which one? So if they're looking for a specific term in the sequence, you would use like the not the sum formula, you would use like the sequence formula. If you're looking for the sum, then you're going to use that sum or that series formula. I hope that makes sense. We can do another one next week. All right. Which equation describes the translation of the parabola f of x equals x squared so that its vertex is at -4, 5? I love translation problems. Here's why I love translation problems. Because they're the same every single time. Not every single time, but if we have a function, x squared, x cubed, circles, like they all kind of follow this same pattern. So your translation says if I have f of x equals x squared, then my translation equation is going to be y equals x minus h squared plus k, where hk is your vertex. So h comma k is your vertex. What is your vertex? Your vertex is the lowest or the highest part of your parabola. Because we know this was defined as a parabola, which is an x squared equation. Now, not everybody needs to know translations, but everybody needs to understand basic graphing, and everybody down to GK core praxis or GK math praxis core needs to understand what a quadratic is. So if we're looking at the vertex, which is your highest or your lowest point, and it's defined as HK, and the formula is this, pay attention to the fact that the formula has H negative. So if you see H is negative, it actually means that it's positive. Because if H is actually negative, if my vertex was actually like a -3, then my equation would be something like x minus -3, because the formula says there has to be a minus sign there, and then I put my value. Well, a negative times a negative is a positive, which makes it a positive value. So if we are looking at the translation -4, 5, I'm going to plug that into this formula that we have right here. So I'm going to have y equals x minus h squared plus k. Now, that negative turns into a positive. Y equals x plus 4 squared plus 5. Now, these are meant to kind of trick you. So they're going to give you answer choices that are meant to kind of trip you up. Now that I have this information, I'm going to look at my answer choices and figure out which one is correct. Well, fun fact, the only one that has an x plus 4 squared is A. So using my answer choices to help me, A is the correct answer. I'm not going to sit here and dwell over it because it's the only one that has an x plus 4. But why is the y value negative? Because these aren't in standard form. This is the standard form of that translation. And because of that, they didn't put them in standard form. So what they did was they subtracted this 5 from both sides of the equation, which means it's a -5. Now, what does that translation even mean? The outside value, or your k value, tells you how much up or how much down you're going. The inside value tells you how much right or how much left you're going. So if we're actually looking at the translation of f of x equals x squared, f of x equals x squared is a parabola centered at the origin, where the vertex is at the origin. If I have a vertex at -4, 5, I'm going to redraw that at -4, +5. Let's say it's around here. That means we went left 4 and up 5. So if we have a +5 right here, that tells me I'm going up 5. And if we have a +4 right here, remember we're going opposite of what's inside those parentheses. That tells me I'm going left 4. So that's how we can kind of read those translation equations. And that does apply for your parabolas, your cubic functions, really any function that can be written into that standard form is that's gonna be how it translates. All right, let's talk about this one, because this one we got stuck on last week explaining it and we froze in the middle of this problem. So let's go ahead and take a look at this problem. Cheryl, I see your question. I'll answer it in a minute. The graph below shows the temperatures in New York City in a specific week. This graph is terrible. It's so blurry, so I'm going to just rewrite them. 43, 53, 50, 57, 59, and 67. What is the average rate of change between the 3rd and the 6th day? So I would say the biggest mistake people make on these kinds of problems is they look at change between the 3rd and the 6th day. They take the 3rd day, they take the 6th day, they subtract them, 67 minus 50, they get 17, and they say, bing, bada, boom, I am done. That is not the average rate of change. That is the change. When we see average rate of change, we need to automatically think slope. Average rate of change equals slope. Unless you are taking a pre-K through 3 exam, everybody needs to understand how to read a graph. Everybody needs to understand how to find average rate of change, or slope. So slope equals y minus y over x minus x. You will often see little 2's and little 1's in this equation. They're kind of useless. It doesn't matter which one you do first, as long as you stay consistent with either the first y and x and the second y and x, or vice versa. So the first step is to do y minus y. Well, when we look at this graph, the x-axis is right here. The y-axis is right here. And if we're looking at the 3rd and the 6th day, my y values are 67 and 50, and my x values are 6 and 3. So yes, I am going to subtract 67 minus 50, but I'm going to put it over x minus x. How do I know I'm going to do the 6 first instead of the 3 first? Because I did the 67 first. If I did 50 minus 67, then I would do 3 minus 6 on the bottom. That's why it doesn't matter if it's y2 or y1, just as long as you're consistent. So 17 divided by 3, if I plop that in my calculator, I get 5.67, which tells me that my answer is actually B. Now, average rate of change is a very common question for my middle school and my high school people, but you would be looking at the average rate of change over a certain period of time on a parabola or a cubic function. All that is slope. So they'll give you a function that looks something crazy like this, and they'll say, what is the average rate of change between time 2 and time 4? All you're doing is finding the slope between those 2 points, even if it doesn't look like a line. So you're going to do y minus y over x minus x, call it a day. That's it. So when we think about average rate of change, what are we thinking about? Slope. Cheryl, would I automatically write down the formula for translations when I see the original problem? I understand how to solve it once I got that formula. That's not a bad plan. Oh my, I'm sorry. That's not a bad plan to write down this basic format, because the format for translations is going to be consistent across most of your functions. All right, let's keep going. Ooh, I love this one. This one's good for everybody in the room. A rectangular playground is built using 234 yards of fencing. The length of the playground is 5 more than 3 times the length. The length of the playground is 5 more than 3 times the width of the playground. About how many square feet does this fence contain? So this is an interesting problem because we're looking at a rectangular playground. It's not one thing, it's another, isn't it? We're looking at a rectangular playground, but they gave us our units in yards, and we need square feet. So we have to automatically think about that. That's one of the most common things that they're going to do to trick you. They're going to use 2 different types of units to try to throw you off. So we've got a rectangular playground that has 234 yards of fencing. Fencing is your perimeter. If it was grass, it would be your area. The length of the playground is, all right, let's talk about what this means. The length is, I love to take words and translate them into algebraic expressions. Length is, length equals, is, if you're translating an algebraic expression, is sometimes, a lot of times it means equal. I don't want to say 100% of the time it does because there's never 100% in math. 5 more than 3 times the width. 5 more than 3 times the width. Often people will do this. Oh my goodness, Joseph, I'm so glad you said that. Yes, I apologize. I can absolutely make my screen bigger. 5 more than 3 times the width. In addition, this doesn't matter. In addition, addition is commutative, which means I can go back and forth and it doesn't matter if I do 5 plus 3w or 3w plus 5. However, subtraction is not commutative. So if I'm looking at a subtraction problem, if I asked you, what is 2 less than 10? What would you tell me? 2 less than 10 is 8. But you didn't do 2 minus 10 to get that. You did not do 2 minus 10 to get 8. You did 10 minus 2. So when we look at an expression that says more than or less than, what it actually means is something plus, oh my goodness, I don't understand. It has something to do where I rest my hand on my screen and I just haven't quite figured out what that is. So when we're looking at this, we're thinking about something plus that value or something minus that value. We are not doing 2 minus 10. So in this case, 5 more than means something plus 5. Now, again, addition is commutative, so you're not going to get the wrong answer if you do it that way, but you would get the wrong answer if this was subtraction. So if I have length and width, or vice versa, it doesn't matter, and the length is 5 more than 3 times the width, I can replace this with 3w plus 5 because they are interchangeable. Now I can add all of those values up and set it equal to 234. However, if I do that, I'm going to get the wrong answer because 234 yards is what they gave us, and we need square feet. So how am I going to figure out feet? Could I exchange, or could I convert those measurements at the end? I could. I like to convert on the front end when my measurements are linear, because then I don't have to do a scale factor. So if I'm going to convert 234 yards into feet, 1 yard equals 3 feet. So how am I going to figure out how many feet 234 yards is? Well, I always like to put my conversion factor here and then figure it out. And then I like to put what I have been given on the correct side of the equation, because I can very easily see that this is a times 3 to go in this direction. So 234 times 3 equals 702 feet. Now I can do this plus this plus this plus this equals 702. So 3W plus 5 plus 3W plus 5 plus W plus W. Now you're wondering how I got that? Because the sides of a rectangle are equal. And we know that the fence going all the way around it was 234 yards or 702 feet. Could perimeter be yards or the area? I'm not really sure what you're asking, Milagros. So if you could clarify your question, that would be great. So I'm going to set this equal to 702. 3W plus 3W plus W plus W equals 8 Ws. And then 5 plus 5 is 10. Equals 702. 8W, subtract 10 from both sides. Equals 692, and divide everything by 8. And we get W equals 86.5. Now, that's not my answer, obviously. That's just W. So now I need to figure out what the length is. So if W equals 86.5, I'm going to plug that into this equation. 3 times 86.5 plus 5. That equals 264.5. That's my length. Then all I'm going to do is 86.5 times 264.5. And we get 22,879.25. Now, here's why the answer choices are incorrect. Because I created this problem. And I guarantee you when I created this problem, I didn't convert the yards into feet when I solved it. Because we're all human and we all make errors. And I guarantee you that what I did wrong when I solved this problem, when I created it, was I didn't convert those yards into feet, which is why we got the wrong answer. So glad to know. I'm just glad that you guys know that I'm human too. So the answer is 22,879. I promise I've done this problem a few times now, and I just need to make a note to change the answer choices in here. All right, let's move on to a matrix problem. This is a very specific problem that I've gotten multiple requests to do. I've gotten multiple requests for a matrix problem. This is not going to be found on everyone's exam. You have to go to your study companion or your blueprint to figure out if this would be on your exam or not. So Shayna found the determinant of the matrix below and got -40 as her answer. What did Shayna do incorrectly when finding the determinant of the 3x3 matrix? Okay, so everybody in the room needs to listen to what I'm about to say. Finding errors in people's analysis is a very common thing that you can find on your exam. Finding errors in student work is a very common thing to find on many teacher exams. So that said, the ability to process through this problem, regardless of whether you do matrices or not, is important. I always like, when I'm doing error and analysis problems, I like to cover up the student's work or the student's answer and solve it myself. Because then at least, especially if I know how to do it, because then I can see the correct answer and try to identify where that person went wrong. Or I can say that they didn't make any errors. So let's go ahead and find the determinant of this 3x3 matrix. So finding the determinant of a 3x3 matrix is tricky. We're going to take this top row and we are going to multiply those values by the determinant of the smaller matrices down below. So when I do this, I'm going to take this value. Oh my. I'm going to take this value right here and multiply it by the determinant of this matrix. Then I'm going to take this value right here and multiply it by, I'm going to change colors, and multiply it by the determinant of this matrix, 3, -1, 5, 2. Then I'm going to take, and I'm going to change colors here, this value right here and multiply it by the determinant of this matrix. Are you following me? So 2 times the determinant of this matrix, which is 2 times 2, which is 4, minus 5 times 4, which is 20. Nope, totally lost. That is okay, Chantel. Matrices are a very, very, very specific thing. So just like go back and rewatch this video because you are taking a 7 through 12 exam. So I'll have to look up to see if the TExES one includes matrices. I am sure it does because matrices are something that is very common. So -4, 1, 3, 2, 5, -4, -1, 4, 2. Then I'm going to do -4 times the determinant of that blue matrix. So 3 times 2 is 6, minus 5 times -1 is -5. And you saw that I made it a plus because it's a negative and a negative. Then I'm going to add. So one key thing when we're finding the determinant of a 3x3 is you do subtraction and then you do addition. So it's a minus and a plus. 1 times the determinant of the orange matrix, which is 12 minus -2. Now I'm going to solve. So 2 times 4 minus 20 is -16. Minus -4 times 11 plus 1 times 14. 2 times -16 is -32 minus a -44 plus a 14. -32 minus 44 is plus 44. So -32 plus 44 is 12 plus 14 equals 26. So Shayna is wrong. So she did not make any mistakes and find the correct determinant. So we know B is out. A, she used the process that one would use to find the determinant of a 2x2 and multiplied the diagonals and then subtracted them. So when we find the determinant of a 2x2, so 2, 5, 4, 2. We multiply the diagonals and we subtract them. So is that what she did? Let's find out. 2 times 2 times 2 is 8. 1 times 2 times -1 is -2, and that's 10. So that's not what she did. She added all 3 of the 2 by 2 determinants together rather than subtracting and then adding. So she got to here, she had negative 32 minus a negative 44 plus 14. But instead of subtracting, they're saying she added all of these. So negative 32 minus 44 is 76, negative 76 plus 14. That would give us negative 62. And that's not going to be correct either, because that's not what she did wrong. She multiplied the top row of constants by the incorrect 2 by 2 determinant. Now, because I've gotten to this point in the game, I'm not going to solve this. I'm going to say, bing, 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 bing. That's the correct answer, because negative 10 plus. I'm solving something really quickly. 10 negative minus 44. I'm going to say that's the correct answer because I've already solved all of the other ones and realized that that wasn't the answer that she got. She did not get 10 as her answer. She did not get negative 62 as her answer. So she must have, at this point, multiplied the top row of constants by the incorrect determinant. I can promise you that a common mistake when solving a 3 by 3 determinant is taking this number and multiplying it by that determinant that's right under it rather than multiplying it by the opposite determinant. But that was a hefty problem right there. All right, let's keep going. Is that not correct? I was taught to copy the first 2 columns, then draw a diagonal to multiply. I'm not entirely sure what you're, Cheryl, I don't know what you're saying. I apologize. So you're saying you were taught to take these columns and then multiply? Message me on Facebook about that one. That way I don't want to waste any more time on this. So message me on Facebook and show me what you mean so that I can better answer that question. All right, let's go ahead and look at this one. And as I get ready to solve this problem, I want you to be thinking about what you want to see next week. What kinds of problems do you want to see me solve next week? Problems are now often coming from special requests from people who are in here. And I want to make sure that I am serving you and the needs that you have. So if there are specific kinds of problems that you're looking for, the answer was D. If there are specific kinds of problems you're looking for, please let me know. I'm more than happy to add that into my set of problems so that I can address the topics that you're looking for. All right. A family took a road trip to Nebraska that required them to drive 830 miles. Joelle, Philip, and Jackie took turns driving. Joelle drove 2 times as far as Philip and 80 miles more than Jackie. How far did Philip drive round to the nearest whole number? So this is a problem-solving problem. This is good for all parties involved, K through 12. So obviously, kindergartners are not going to solve this problem, but the test is not just for kindergarten. So this is going to be good for anybody. Thank you, Cheryl, for the reminder. Margaret, you need elementary problems. Awesome. I will make sure to include some of those next week. This problem is going to be perfect for elementary, though, and you'll see why in a minute. So we know that Joelle, Philip, and Jackie took turns driving the 830 miles. So I'm literally going to write Joelle plus Philip plus plus Jackie, and I'm going to call Jackie C just because that letter is in her name and I've already used J, equals the 830 miles. Each of them drove some miles and it equals 830 miles. Joelle drove 2 times as far as Philip. Joelle drove 2 times as far as Philip. So I literally took those words and translated them into an algebraic expression or equation. If Joelle drove 20 miles, that was 2 times as much as Philip, so Philip only drove 10. So I'm going to do 2 times what Philip drove to give me Joelle. And Joelle drove 80 miles more than Jackie. 80 miles more than Jackie. So what am I going to do from here? I am going to replace different variables in my equation so that I can figure out what each person drove. So if I replace the J with 2P, I'm still going to have multiple variables. I'm going to have 2P plus P plus C. That's not going to help. So from here, there are a ton of different directions we can go. There is not one correct way. So with that said, just because I do it one way doesn't mean the way that you're about to do it is wrong. I am going to replace J with 2P, and you're going to see why in a minute. Now what do I need to do? Now I need to replace the C, but I need to replace the C with something that is in terms of a P, because I need all of it to be the same. So watch what I'm about to do. How am I allowed to do that? Because what Joelle drove is equal to 2P, and what Joelle drove is also equal to 80 plus C, which means all of those are equal. So I can, if J equals this, then I can put this in place of the J right there because they're all equal. So 2P equals 80 plus C. If you get confused, please let me know. I'm more than happy to stop and go back. So now I'm going to get C by itself because I want to replace this C. So I'm going to erase the 80, minus 80 from both sides. So C equals 2P minus 80. I can't subtract those because they're not like terms. So now I have 2P plus P plus 2P minus 80 because that replaced this C equals 830. Now I'm just going to combine like terms. 2P, P, and 2P, that's 5 P's, minus 80 equals 830. I'm going to add 80 to both sides and then divide by 5. So 830 plus 80 is 910. So 5P equals 910. Divide both sides by 5, and P equals 182. Now, is that my answer? Yes, it is. My answer is 182. Why? Because they asked how far Philip drove, and P was Philip. That's why I chose to replace everything with something that represents a P. Now, could you have replaced things for J's or for C's? Absolutely. We could have put everything into C terms. But then if we got C equals I don't know, something. Let's pretend it was 230. Then that wouldn't be my answer. And I would have to take that and plug it into one of my equations to figure out what my answer actually would be. Does that make sense? All right, we have time for one more problem tonight before I turn it back over to Dr. A. So let's do this one. At a local store, a pair of jeans costs $72, a pair of shorts costs $54, and a shirt costs $38. If a customer purchased 2 pairs of jeans and 3 shirts for a total of $276.06, what percentage of tax did the customer pay? So the first thing I want you to notice is it was 2 pairs of jeans and 3 shirts. They gave us information in this problem that is absolutely positively useless. This person did not buy shorts. So this 54 will never get used in this problem. Do not be tricked by that number and think that it's necessary to use just because it's in the problem. Now, I want you to think about how we would solve this if they asked us for the total. If they asked us for the total, we would do 2 times the cost of the jeans and 3 times the cost of the shirt. And then we would multiply that by the tax. We would multiply that by whatever the tax is, the tax percentage, and then add that tax back in. So let's go ahead and just find the raw cost of the materials or what they purchased. So 2 pairs of jeans plus 3 shirts. So 2 times 72 is 144. And 3 times 38 is 114. So 114 plus 144 equals 258. That's how much money they spent. But they're asking what percentage of tax did the customer pay to get a total of this. So there's 2 ways I can do this. I can use my answer choices or I can solve it algebraically. Today, I'm going to use my answer choices. So I'm going to multiply 6% by 258 and then add that number back into the 258. So 258 times 0.06, because remember, when we translate a percentage into a decimal that we can actually multiply, we take our decimal point and we hop it 2 places to the left. So that's 15.48 plus 258. And that equals 273.48. Not the right answer. So I'm going to skip to the 7 because I'm still a solid $3 off. And 0.5% is not going to make a huge difference. And then I can know whether I need to go up or down. So now I'm going to take 258 times 0.07, and that equals 18.06. Add that to the 258, and look at that. We get 276.06. So C is our answer. Now, if you wanted to solve that algebraically, you could have done, for my algebraic people, you could have done 258 times X, which is the percentage that you're looking for, plus equals 276.06 plus X, that value, plus 258. So you can do it algebraically. I think I'm just going to confuse the living daylights out of a lot of you, so we're just not going to do that. Once you get this number, answer choices are your friend. So, let's just leave it there. All right, we have run out of time for tonight. Let me know in the comments what you want to see next week from me. And summer is kicking off for most of us. So I hope that you have a great summer. My heart is with those of you who are in Texas right now. I can't imagine what those people went through, and that's all I'm going to say. So that was really hard as a new mom for me to deal with, as I'm sure it is for a lot of you, because we're all in the education field. So that's all I'm going to say is my heart and my prayers go out to them, and I'm trying to figure out what I'm going to do and our family's going to do to support them. That said, let me know in the comments what you want to see. Could I set it up as a proportion? That, I'm not thinking we could set that up as a proportion. If I am incorrect, please let me know, but I do not think we could set that up as a proportion and get the correct answer. Okay, all that said, I'm going to turn it back over to Dr. A. Let me know in the comments or tag me on Facebook. If you don't let me know in the comments before Dr. A closes out tonight, I will not see your comment. So you can always tag me on Facebook throughout the week as you're studying and let me know what you want to see from me next Wednesday. It was so good to see some familiar faces. I hope to see you all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great. But she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.